where you get the chance to network with community members, and we host workshops that teach you to translate machine learning to code and real-world applications. So today we are joined by Pedro Saleiro, who is going to talk about how to deal with bias and fairness in machine learning models. Pedro is a senior research manager at Somaieh Research, where he leads fairness, accountability, transparency, and ethics research groups. He is responsible for several initiatives related to improving model explainability in the context of financial crime prevention, bias auditing, and algorithmic fairness, and experimentation and A/B testing. So previously, Pedro was a postdoc at the University of Chicago and a research data scientist at the Center for Data Science in Public Policy, working for Raed Ghani, developing new methods and open source tools, and doing data science for social goods projects with government and nonprofit partners in diverse policy areas. Pedro was a data science mentor at the Data Science for Social Goods Summer Fellowship in 2018. I'm so excited about this session, and I'm looking forward to the talk, and I hope you are too. So first, Pedro is going to make his presentation uninterrupted, and then we have a discussion for the remainder of the session. Feel free to add any questions you have in the live chat, and I make sure to relate them to Pedro as we discuss. So with no further ado, Pedro, the floor is yours.
Thank you so much for the kind introduction. It's really a pleasure to be here to kind of discuss with you the work we have been developing in kind of bridging the gap between research and practice in this topic of algorithmic fairness and bias in AI. Most of the slides I'm going to present here are based on our KDD 2020 tutorial. I believe the URL has been shared in the invite. I really want you to explore this resource. It's in web page. We have besides the slides, we have also notebooks that run on Google Colab, in which you can audit for bias and fairness a machine learning model. You can try out different bias reduction techniques, and we even have some exercises around understanding fairness and bias and risks in AI. And it's a very useful resource. And I'm trying to kind of summarize what we presented in a 3-hour tutorial during KDD in this half-an-hour presentation. Before that, I want you to invite you to go to solveforgood.org. It's a marketplace for data science for social good projects that Raed Ghani started in these current times of pandemics. We need to have some way of connect with volunteers in projects, and I invite you to have a look and register if you have the opportunity. Most of this work has been based on the work carried out by the Center for Data Science and Public Policy, directed by Raed Ghani. And we have been interacting and working for many different organizations, so social impact organizations, in problems that can be solved using data. But one thing that we have noticed is that often when we are developing these data science for social good projects is that we need to balance efficiency, so reaching out to people that really need help, and equity. How can we make sure that no people from any specific demographics or group are left behind in terms of these public policy projects? So the overarching kind of statement we have is that our policies and systems need to reflect our values. And the question is, how can we develop these, whatever name you pick, AI, ML, DS systems that help make decisions leading to fair and equitable outcomes? And really the question is here about the highlight on help make decisions. And because often in public policy, social good projects, there is a human in the loop. So the AI, the machine learning model, thankfully, is not making automated decisions, is here to inform a human expert on which decisions should be made, and also why outcomes, because there there's been some discussions about concepts of treatment, concepts of equal opportunity, and really believe that what really makes sense is to measure outcomes. So the true impact of these decision systems in the society. And so the goal is not to make the machine learning model fair. It's not enough to do that. The goal is to make the overall system and outcomes fair. So we might have a machine learning model or several machine model interacting. We have actions, so interventions that are carried on people, and we have outcomes. So the policy project is resulting, is being effective, is being equitable in terms of outcomes. We can think about, for instance, I've been working projects for preventive healthcare on diabetes, and our goal is to reduce the prevalence of diabetes in the society. So it's really important that we make sure that we measure the effectiveness of our data science systems and our policy systems. Also, in terms of, are we reducing the prevalence across groups? In some notion of equity and fairness that I'm going to discuss, how can we find which definition makes sense? And also, it's important to make sure that we have some sort of baseline comparison, because often these systems are incremental, and we need to kind of compare if we are replacing human experts or if we are augmenting human experts in decision making with some sort of automated system. It's really to make sure that we understand what are our baselines and what makes sense to compare against. The models and the current system is to the historical current human decisions. And there has been lots of buzz around bias in AI, sources of bias, and sometimes there is this misconception that the only source of bias is data, and that's not actually the case in practice. First of all, the world is biased, and data is just an artifact, and data reflects these processes that happen in society, in our world. And we have the AI ML pipeline, and because there are humans developing this ML pipeline, every decision that is made in this pipeline can introduce some sort of bias. Also, if there is a human in the loop, and if the human has some sort of unconscious bias and overrides the recommendations of the machine learning model for specific groups of the population, then the human might be also a source of bias. Also, the actions we are performing, we might have heterogeneous treatment effects. So different groups of population the actions might have different effectiveness for different groups of population, and this is reflected in the outcomes. So in terms of sources of bias, we have sample bias. It's kind of a classic notion of, are we developing our AI ML system using relevant and representative sample of the population in which the model is going to be used on? Also, often, because there is an artifact, we might have heterogeneous quality in terms of the data collection. We can think about working projects in US in which, depending on specific locations in a city, depending on different funding of public institutions, the quality of the data involved in translation process from paper to digital formats, the data quality might be different across different groups, and this for sure will introduce some sort of bias. We have label bias. Label bias is striking problem in AI because machine learning really relies on labels. And if we have some sort of issue regarding of label noise, if, for instance, we have the example of if we want to predict recidivism and we are using arrests data, arrests might also be biased across different groups of the population. We have the case of over policy in US in specific minority areas, and over policy leads to more arrests, and more arrests will create some sort of label bias. We might also have labels that are correlated to specific features for one groups and another ones for other groups. So this is also a source of bias. As I mentioned before, every step on machine learning pipeline, we are introducing some source of bias. For instance, when we store and link data from the different data sources, we might record linkage. We might even introduce two types of bias, because we have one record that should be associated with one person, and because of problem in linkage of the data, this will be a duplicated, or we have many records that should be just one. So we are introducing some sort of bias in terms of group sizes and prevalence of the groups, but also we're introducing bias in terms of feature distributions, because before those values should be aggregated in just one row, but because we have duplicate records, we have issues with record linkage. These are multiple records, and this will affect the feature distribution. But any step, really, we can introduce some sort of bias. The imputation we are doing with missing variables, how we group people for, usually we create the other category, but the other category, we are mixing together people that actually might be very different, and we are imputing average values, and this for sure will introduce some sort of bias. The metrics we optimize for, even the threshold we pick for deploying our models and for evaluating our models, the threshold has a huge influence in terms of disparities across groups. As I mentioned before, there might be some action intervention bias, heterogeneity in the effectiveness of intervention, and even discriminatory overrides. And so how do we make the overall systems and outcomes fair? It's really in a continuous and ongoing process. We should define equity in the beginning of the projects. It's really important to define equity during project scoping. Then we need to measure and detect the bias. We need to understand what are the root causes of bias. We need to improve fairness. We need to mitigate the impact of the systems in the outcomes, and we need to continuously monitor and evaluate. And this is an ongoing process, never-ending process, because as AI ML systems run forever, and they have a very dynamic life cycle, bias can cripple in every time. So it's really important to stay vigilant and monitor continuously. So how can we measure bias? Bias in this context is different from statistical bias. It's really about disparities across different groups in our sample, in our population. And there have been many different metrics suggested to define fairness, bias, and fairness. Actually, we get this table from Wikipedia, and this is basically based on the confusion matrix. And every metric that is derived from the confusion matrix can be used to compare different groups. So for instance, we can calculate false positive rate for women versus men, for one group versus the other for different attributes. And for every metric, we can compare groups based on different metrics. So it's very hard for someone arriving to this field of AI ethics, and people with good intentions that want to audit their systems. It's very hard to navigate this sea of different metrics. And there is also some trade-offs implicit here, and we cannot achieve simultaneously different definitions of bias. For instance, one well-known result is this proof that we cannot achieve at the same time false positive rate parity and false discovery rate and false negative rate parity if the prevalence of the two groups is different. So basically, we cannot balance false positives and false negatives across two groups if the prevalence of two groups, the base rate, is different across groups. But does that mean we cannot achieve fairness in machine learning models? Because often these trade-offs are being used as somehow an excuse to not care about fairness, because people might say, it's impossible to obtain absolute fairness over all metrics that you define. So this is a pointless goal. And the Compass news story of ProPublica is really an example of that, because Compass is about different people arguing for different fairness and bias definitions. So if you are aware of the story, basically ProPublica, this magazine, they audit Compass, which is an algorithmic risk assessment system used in US, and they realized that the false positive rate for African Americans was twice as for Caucasians. And North Point, which was the company that developed this algorithmic risk assessment algorithm, Compass, they claimed that they were aware of that, but their fairness goal was to equalize, to get precision calibration on precision, which means that they balance false discovery rate across groups. And then the discussion became which fairness definition makes sense. And I think the message is really important is there are some nuances here, and it's really important to make an informed discussion with every stakeholder involved in these projects, from the subjects that in which the decision will affect their lives, from the stakeholders, from the decision makers, from the developers. And it should not be a one-sided decision which fairness definition makes sense for a specific application. It should be discussion including diverse backgrounds and diverse viewpoints. And we came up with this fairness tree, which is based on our experience in data science for social good projects. We tried to help people to narrow down the options for specific fairness definitions based on the application. And our root question is really about if the interventions are punitive or assistive. If we think about bail determination, as the case of Compass, we're talking about punitive interventions because the bail amount will be much higher for people considered as high risk, and the case of fraud detection systems in which we are blocking payments is a punitive setting. If you are thinking about assistive settings, we can think about, for instance, preventive healthcare or distributing some sort of benefit. If we think about are we reaching out to people and help people kind of prevent developing diabetes, for instance, is an assistive intervention. And based on these categorizations of the costs of false positive and false negative, we can kind of divide the range of options for different metrics. And it's really about if the intervention is punitive, we should care about false positive errors. If the intervention is assistive, we want to help individuals. So it's about, are we missing people that really need help? So we should focus on the distribution of false negatives or true positives across different groups. And especially in public policy settings, often there is a problem of budget and resource allocation. And sometimes we can only act on a very small fraction of the population that really need help. And if that's the case, we would be comparing false negative rates that will be very high across groups. So the notion of disparity will basically show that the system is fair. But because we are intervening in a very small fraction of the population, we should not look to false negatives, but actually to true positives, because then we can see the rates of help and how help is being distributed across groups. So we recommend recall parity if we are only, in terms of assistive intervention, if we are only able to help a very small fraction of the population. Of course, if we can help most people, then it makes sense to look to false negatives. And then really depends on which denominator we care about. Do we care about just the group size of different groups? It's basically, do we care about the percentage of people that not receive assistance? Or do we care about the label positive? So meaning that the people that actually need help, I know that this might be a little bit overwhelming in the beginning to think about all these definitions. At the end of the presentation, I'm going to share a book chapter in which we really dive in these definitions, really try to make them clear and what makes sense. But also, it's important to not pass a message that we are being too prescriptive. So the fairness tree is not really the answer, but is really intended, as I mentioned before, to when different stakeholders discussing what fairness and bias definitions, what are the fairness goals for the project, is really the fairness trees help to start this conversation, help to guide the conversation, helps to avoid rabbit hole kind of discussions. And of course, ultimately the fairness metrics that are chosen are really dependent on the context and on the stakeholder values. And we really believe that it's really important to monitor. So the old cliche of Lord Kelvin, if you don't measure it, you can't improve it. So by making bias audits standard in every ML pipeline, will create awareness among the stakeholders. And it's not that executives or product owners or product managers or other people involved, they don't care about bias, is that they are not aware of the bias of the systems. And as soon as we unfold this dimension, as soon as we create awareness about bias of the systems, then this can become a KPI. And then it's really about us. If you present the issue or a problem to an executive person, if they don't know the problem, they will not try to solve it or try to optimize for it. But as soon as they know the problem, they will make sure that that's also part of the effort of the institutions. So that's why we develop Aequitas or Aequitas. It really depends on how can you pronounce it. I really invite you to go to GitHub. I invite you to install. I invite you to start. I invite you to share it. It's the tool was developed because of the gap between research papers and practice. So we wanted to make a tool that would make these audits for fairness really intuitive and easy and seamless. And we think of the tool as some sort of post-modeling step. So when we are testing and evaluating our machine learning models, we run the Aequitas. So in this case, it would be a data scientist kind of persona that will run the audits, but also the policymaker or the other stakeholder that receives the model, that is the user of the model, should audit independently the machine learning model before accepting it for deployment, and should make sure that it's continuously monitoring. As we monitor the performance of machine learning systems in production, we should also monitor the fairness of machine learning systems in production. So what do you need to audit predictions of a model? You need the predictions. The way Aequitas works, really out of the box, we kind of need ones and zeros in predictions. So based on your threshold, you find which rows will be a 1 or a 0 in terms of predictions. Then the attributes that define the protected groups can be ethnicity, sex, age, and should be categorical variables. And then if you are interested in disparate errors, as I mentioned before, you should provide the labels for the predictions. If you suspect there is lots of label noise, or if you have some problem or rejecting inference in the sense that you, because of the decision, you don't see the outcomes, as we get, for instance, in the bill determination, or if we block a payment, we don't know if the transaction will actually be fraud or not, then you are more restricted to metrics that don't depend on the labels, so are more distributed metrics like demographic parity and other metrics. So it's the workflow is very easy. You provide the predicted scores and the labels, you provide the attributes, you define your metrics, and you get the results. You can use it through a web audit tool. So this is more thinking about non-technical people. Basically, you can download the open source toolkit, and you can run in localhost kind of a web interface, and you can upload the data and configure with the clicks, point and click, and get the report. For more data science kind of users, the to go would be the Python library. So it's very easy to integrate in your notebooks, and it's very easy to run the audits. If you think I'm more on corporate kind of a setting, we have a command line tool that kind of audit in batch. I actually use this command line to interface for auditing thousands of models in a database. So you can pass a SQL query, you get the bias results that directly exported and again inserted in the database in a different table called Aequitas. Very shortly, in a few minutes, I just want to highlight some of the tensions we have when we are auditing machine learning models for bias and fairness. This is an example of a project in which we have 1 million patients' data from 2006 to 2018. Our label is the risk of developing diabetes in the 3 years after a doctor visit. And the intervention, the action, is getting personalized preventive healthcare to most at-risk people. Our performance metric was recall. Our group metric is false omission rate for bias. Our protected attributes are age, race, and sex. And we are auditing a test set with 200,000 patients that visited a doctor during 2014. And we have a 3.4% prevalence. So 7,000 people developed diabetes in 3 years after these visits. So we started, as I mentioned in the beginning, we need a baseline, and we use as baseline the doctor's decisions to screen people for diabetes as a proxy for a prediction of the doctor of the risk of developing diabetes. And we realized that there was some high error metrics for specific age groups, but we were more focused on race and ethnicity, and we realized that Native American and Native Hawaiian had slightly higher false omission rates. So this is a doctor practice. So this means that the doctors were missing more people at risk for Native American, Native Hawaiian proportionally regarding the predicted negative decisions. So people that don't get screened, they actually end up developing diabetes. And here is the results of running Aequitas in thousands of models, and we have kind of a macro level multi-model visualization. And we see that in the x-axis, we have our performance metric, which is recall at 5% of the population. And here we have the false omission rate and the false omission rate disparity between groups. And we see that there is this trend on as we get better performance, the false omission rate goes down. But when we look to the disparities across groups, we kind of see that there are more nuanced differences here. So some models have higher disparity, although they have higher performance. And picking up the model that has the highest performance, which is the blue one, compare with the orange one. Orange one was the doctor's practice. We can see that our machine learning model is able on the test set to improve this metric for every specific group that we cared about. But in terms of ethnicity, compared to doctor's practice, we now have some more disparities across groups. And now we pick the model that has the best disparity across race. And what we find is that this mustard model is still better than the doctor's practice in detecting people at risk across different groups, different demographic groups, but is slightly worse than the most effective model. So here the trade-off is, are we willing to aim to balance for fairness across different ethnic groups? But the cost for that is to not be as efficient as we could be if we pick the model that has the highest performance. So basically, we are sacrificing in overall detection rates, so the ability to help people that are actually developing diabetes, in exchange to have a system that is more equitable. Let's have some additional considerations of what would happen over time, and I'm really wrapping up. If we think about diabetes prevalence over time. Imagine that we are here over time and we have, for instance, non-white prevalence for diabetes, and this is really an hypothetical example, and white prevalence for diabetes. And here we start deploying our machine learning model. And if we pick the one that is more efficient, so the one that has disparities, but really catches the most people that need help, that are at risk of developing diabetes, what's going to happen across groups is that over time, one group of the population, if we assume that the treatment is effective, of course, this is in a hypothetical scenario, we'll end up some point in time in which there is a huge gap, a huge inequality in terms of prevalence of diabetes, and then diabetes will become almost a disease that is exclusive for one group. So it's really here what is at stake is if we balance fairness and efficiency, and how that can affect over time the society that we want. And maybe one possible alternative would be if we force somehow the group that has highest prevalence, if we allocate more resources in the beginning in this group to kind of bring that group to the levels of the group that has lowest prevalence, and then move the groups together, then we would make equitable goals kind of the priority, not efficiency. So this is a continuous workflow. There are lots of things you can find out in the tutorial. I'm really over time. I just want to. This is all available in the fairness tutorial webpage. I highly recommend you to have a look to our book chapter in the Big Data and Social Science book, in which we really define the metrics and we discuss the implicit choice in terms of fairness trees. And thank you.
Thank you very much, Pedro. That was very interesting, and I really enjoyed your presentation. So, some of the folks on the chat were asking if this presentation is available on the link that you provided on the GitHub page.
Yeah. So probably I'm just going to present again. Just a second. I think it's good to kind of walk people through. So the link you shared is this resource here. So people can find there is a YouTube video from the original KDD tutorial. There are the slides, and there are static Jupyter notebooks, and also people can find Colab notebooks, Google Colab. They just need to have a Google account, and we even have the breakdown sessions, kind of case studies, so people can have a look at that. I really invite you to try out all these resources.
Great. So thank you so much again for the presentation. I have a few questions. I'll start while I'll give our audience a few more minutes to post their questions. So you mentioned that the focus of your toolkit for measuring the fairness was actually on the impact of the machine learning model. So as you mentioned that the biases can happen at any stage during the machine learning pipeline. I would like to know that what was the reason that you guys focused on the impact of this addressing biases? I mean, the impact of the decision and the prediction that's made by this model.
Thank you for a question. It's really important to clarify that. Is really because if we argue that discrimination and algorithmic discrimination and AI discrimination and AI is propagating the biases and raising inequality in the society, that is measured on the outcomes. So, for instance, the example of diabetes prevalence. If we want to claim that AI is increasing inequality or is discriminatory, the way to measure that is on the outcomes. Is this system helping more people from one group than another group? Is the error rates of these systems in more groups than in other groups? And this is measured in the outcomes. Is the actual impact that we have on people's lives? Because we can have a fair treatment, We can even claim that everything is blind to any demographic attribute. But at the end, if our decision-making system produces outcomes that are disparate across groups, that's actually what really going to impact people's lives. So our paradigm is, you can try different things in the pipeline. You can try different data samples. You can try different linkage methods. You can try different algorithms. You can try different metrics, but you also test at the end on the impact. And then you can make informed decisions. So then you can perform some sort of data mining in your process, so you understand what are the causes of bias. Because if you change something here, how that affects the outcomes. So that's our paradigm.
Mm-hmm. Mm-hmm. Okay. Thank you for your answer. So what I understand that not addressing these fairness issues or biases, it can actually have such a long-term impact that that's why how important it is to make sure that the impact of these projections are fair across the year's group. So one person from the audience is actually saying that they love the fairness tree, which I did too as well. It was very, very informative and kind of it explained how to address an issue in a very structural format. So a question is coming up from the audience. It says, I love the fairness tree, but what if different stakeholders are concerned to preserve equity among different groups and thus favor different fairness metrics? So how do we adjudicate these disagreements?
That's also a very good point. So, as a disclaimer, after presenting fairness tree, it's not really the complete answer. It's really a starting point for the discussions. I already work in a project in which we have different groups of subjects that were affected by the systems, and I am going to be more concrete. Think about a child welfare risk assessment systems in which the system is predicting the risk of child abuse. So you want to detect the children that are at risk. So you care about the children, but you also don't want to be too invasive or too intrusive to the parents. So we have two different groups here, and different stakeholders might favor equity goals for the parents or for the children. And I think if that's the case, is really much more nuanced, the discussion. So it's really measuring there is people and experts in risk assessment that their job is to quantify the cost of the risks, the cost of harm. And it's really important to have this notion of quantifying what is the cost of harm to the different groups of people. So what is the cost of missing people that are abused, children that are abused? What is the cost of having really intrusive social stigma, kind of social workers kind of chasing out parents, knocking on the door at 4 a.m. in the morning? What is the social stigma that creates? So this is the cost. So it's really about this framework of risk assessment. Stakeholders really need to, and actually, I take the opportunity to refer to something I believe you are all aware. Canada is really progressive in terms of impact assessment. And last year I was at Ivado, Montreal in a summer school, and there was this person from the government of Canada about algorithmic impact assessment in Canada. And the algorithmic impact assessment in Canada, I invite you to Google Canada algorithmic impact assessment if you don't know it, really frames this in terms of risk assessment. So fairness tree will help as soon as we quantify what are the costs of false positives and false negatives for different groups. We find out which metrics we care about. So we pick one metric for the parents, we pick one metric for the children. And then we audit the models and we kind of create compromises and we try to mitigate risks and we try to select a model that tries to balance our equity goals across these different groups.
Okay, wow. Thank you for the response. So what I hear that is the subject area, understanding the subject area and what impact we are trying to make is actually a very important factor about defining the fairness in our model. So I'm going to go back to that decision, to that fairness tree that you mentioned. So I remembered that it's so important to identify that, are we going to care about individual fairness, or are we going to care about the group fairness? And as you know, there are so many various definitions, as you mentioned, that depending on what is it important for us. Is it the false positive that we're going to focus, or is it the true positive true positive rate that we're going to focus? So what are your thoughts about how to choose the definition of fairness that best suits our model?
Actually, I don't know if this is going to be controversial, but I take the opportunity to actually say that individual fairness, it's almost impossible in practice. And I tell you why. So think about two individuals that they get practically the same score from the machine learning model, but just on the fourth decimal point, one is higher value than the other. So they have, for instance, a prediction of 0.8123 and the other one 0.8124. These data subjects, these data points, are almost identical in many of the attributes they get on the light of the machine learning model. But because we are talking about real life systems and not theoretical research or simulations, machine learning models are often deployed based on a threshold. We have a limited specific point in the ROC space in which we deploy the models. And if the threshold is really about 0.1223, this second individual is not going to be classified as positive. So this is kind of a business constraint, it's a deployment constraint. It's because the nature and how we deploy these systems, individual fairness is an abstract theoretical concept. If we think about macro socio-economic impacts of AI systems, we should go for group fairness metrics, because group fairness also help us in terms of statistical significance, in terms of robust of the values we get in these metrics, in the sense that we want to make sure to understand if these differences in the predictions across groups, are they because they are noise or they are systemic and systematic. So that's why group fairness are the go-to metrics in terms of auditing systems for bias and fairness. Then in terms of the different nuances on the leaves of the fairness tree, that really depends on stakeholders, and it's even more nuanced which metric you should choose or not.
Mm-hmm. Thank you. Okay, I'll go to, while I'm waiting for more questions to come on the online chat, I have one more question. So what you mentioned about using fairness as one of the key performance indicators for our in an organization. So how we can get the buy-in from the senior management to make that as a key performance, because right now this is not a mandatory performance for an organization to evaluate the model and see they are fair and then check in. So now we get certain industries, they do that, but not all of them. So what are your thoughts about how, kind of maybe from practitioners' point of view, how our practitioners can make sure that these fairness indicators become something as a key important indicator in our organizations or in our industry?
I actually love this question because I've made the jump between public sector during my postdoc at U Chicago, and now I'm in the private sector. And actually, it's something that has been arguing with different people and trying to kind of create a rationale around that. And I really think it's twofold. One is about regulatory law. In specific application areas, there are already regulations in place. They might not be prepared for the digital era, for the AI era, but as you mentioned, we have specific scenarios in which we already have regulation, and there's a question about being compliant and about compliance failure. And I work in financial industry, and this is really a issue for our clients. But that is kind of the non so interesting reason. What I think is the most interesting reason is companies, brands, in terms of brand awareness, companies and corporations, they have values they strive for. They have mission, they have core values. And we live in a reality in which there is this disconnection between what companies say they strive for and what actually is the practice, because there is this lack of control in AI, there is this lack of awareness, and I think there is a huge value proposition for companies to say that we actually have systems in practice that correspond and are aligned with our what we say and our mission and our core value. And is really also in terms of the public, I really believe the public is getting aware of the issues in many of the technological companies and big tech companies. There is awareness about kind of a back to basics values in terms of climate change, energy efficiency. There is a set of values that people strive and people care about. And if companies present themselves as equality, as equity, as fairness being one of these values, I think there is a market for that. I really believe there is a market for that. And also, the question of trust is so important. Even if it's not appealing to say that fairness is a goal and of the market, there is this problem of trust and safeguards. If companies make sure that their AI is not as big tech companies that discriminate or that manipulate us, and all these negative effects that are very recent being discussed about elections, about social dilemma, and so on and so forth, at least the most conservative companies might be convinced by these safeguards, this kind of make sure that our systems are robust in regarding equality. So I think there is kind of there is value proposition in fairness. Is a question of really posing in position and really frame in specific areas.
Mm-hmm. So what I hear is that we need a well-established regulation for various industries to make sure that we adhere to the fairness criteria in our machine learning models. And we have another question from the audience. So the question is that, can we consider the makeup of a machine learning AI industry itself as a key outcome, and that key outcome as well? So which means that systematically unprivileged groups are active and empowered in the industry. So can we consider that?
Can you repeat the question? I'm not sure if I really followed the framing.
So the question is, can we consider the makeup of an AI machine learning in industry itself as a key outcome? So I think probably this refers to when we discussed about the outcome of these models, but maybe this question is mainly relevant in that how this industry, I mean how the AI industries are performing. Maybe that would be a key outcome. But feel free to elaborate on your question. And I can make sure to reflect that.
So I think it's very in line with what I've said in the previous question. I think there is definitely a room for companies to be transparent and actually disclose to the public the results of their bias audits, their regular bias audits, so people can trust that there is no any sort of discrimination in the company products and in how the products are being used. I definitely think there is a value proposition in that, and to make sure that we strive for equality.
Okay. So I have one last question while I'm waiting. I actually really like that you guys have the code available on GitHub, so we can all go and try and test it.
And you can also start it. You can also start the repo, and you can share with your friends and your connections. I think that's really important for this is an open source project, and it's really, we have Google and Facebook, they can come up with their own fairness libraries, but I think it's really important to support these more kind of movements that start from the public sector and from the open source community.
So we have one more question from the audience. So do you have any insight as to what people can do at the individual level to have an impact on this?
Oh, yeah. You should all be champions of fair AI. And actually, I really believe we need to have some sort of optimistic viewpoints in terms of how can we use AI for change? Because as we know, there are lots of risks associated with AI because of its scale and automation. But if we design AI with fairness and equity goals in mind, we actually can use AI as an agent for change, because we might have a biased process in the world, we might have a bias and systemic discrimination in our society. But if the key stakeholders get involved and they use fairness as a key goal and main goal when developing a system that is going to be automated decision-making systems or AI system, then we can actually use AI for good and AI for change and AI for improvement. And I really think everyone should kind of be a champion of this idea of using AI for change, AI for good. And the really question is to make sure that every stakeholder is involved, nobody is left behind. We have that diverse backgrounds involved. It's not just the data science people that need to make decisions. It's not just management and senior management that should make decisions. It's not just the public and government organizations. Is everyone involved? Is the communities, the subjects that are affected? Everyone should have an informed discussions around what means fair in a specific application, and what goals should AI be try to achieve.
Okay, thank you. And I'm going to end with one last more questions. And if you have to name a challenge, one challenge that you've had during development of this toolkit and implementing this toolkit on any of the models that you've developed or a company has developed, what would be that challenge that kind of comes out? So what can you name a challenge or two, and what do you think you could have done maybe differently that could help?
I think one main challenge in terms of regarding the technical aspects of the tool is that it needs the demographic information, and sometimes the demographic information is not directly available. And there's also something that individuals can also be champions for that, because I've witnessed big financial corporations saying that we don't know the gender of our applicants, we don't collect any gender information. But this is actually the first step to not actually audit, because if we don't collect the demographic data of our subjects, we will not be able to measure and to see the discrimination across different groups. So there is this kind of what cannot see doesn't exist, and I think it's one of the challenges is that we cannot audit if we don't have demographic data. And the other challenge is regarding label noise, because most of these metrics depend on label. And if we have some sort of label noise, there is a huge challenge on really understanding if we are not getting biased results from the bias audits.
Very good point. Yeah, noisy label is something that is probably for another discussion, maybe another time. But thank you so much for the presentation. That was really great. And I would like to thank everyone who joined this presentation. Please make sure to sign up and subscribe to our YouTube channel and get the notification for our future events. We have a lineup of very interesting presentations for AI ethics coming in the next few months. So thank you all and have a great rest of the day. Bye.